This Coaster Vision recording of an eClinic by Seth Neumann about a new PC board-based Keep Alive was recorded August 22nd, 2020.
Let me just kind of take it from where Phil left it. Phil had a need for some simple Keep Alives that wouldn't break the bank, and did some internet research and found a nice basic circuit for a Keep Alive using what are called supercapacitors. So supercaps are something for our purposes between a rechargeable battery and a capacitor. You can certainly build a little capacitor system that you can put onto many DCC decoders that'll give you a few seconds of power to get past a little bit of dirty rail, but they don't do as well if you've got, say, dead frogs, or you need a little bit longer period for it to operate. So the supercaps work, but they have some limitations because while they've got a tremendous amount of capacitance, normally we think of caps in the range of a few to a few thousand micro or millionths of a farad. These are 1 farad each. So that's a tremendous amount of power they're storing. And they don't need a fancy charger like a rechargeable battery would. So that's kind of nice too. The disadvantage is the technology that's used to make them so powerful means that they cannot tolerate a lot of voltage across them. So you have to stack several of them up to get the 12 to 14 volt range we usually expect to operate a decoder. Anyhow, the point is it keeps you running. Here's a version of the circuit that Phil was pointing at. Turns out the article was by Larry Puckett, who has the model railroader column, or at least at various times has done the model railroader DCC column. And it's a nice simple circuit, generally uses fairly common components other than the supercaps. The difficulty really was translating this design into readily available components that you could buy from, I use Newark and DigiKey, but virtually any of the electronics part houses that will deal with orders the size of hobbyists or clubs or small manufacturers like myself. One caveat here is that some of the decoder manufacturers may not honor the warranty if they think the problem came from a Keep Alive that wasn't theirs, although that would apply to brand Y and Z as well as theirs. So just need to be aware of that when you start soldering onto these boards. Most of these guys either have a flat rate repair charge or just a no questions asked warranty. And believe me, there's enough margin in there for them to do that.
Seth, if I can comment, it's just like a car. You don't install the turbo till it's out of warranty.
That's right. That's exactly right. Or, you buy an old beater and rebuild it, and the whole point of it was to rebuild the old beater. Yeah, I think many of us have had that experience in our wasted youth. This is a much more economical hobby in that respect. Okay, so pros and cons. It's you can build very inexpensive ones. So it's great for a club project where you want to build a bunch. They're not fancy, but the price is right. It's good if you have a fleet. I'll give you some little anecdotes about that. If you space wire them, the good news is it's easy to kind of assemble them to take care of whatever kind of space you have in the cavity in the locomotive. But what's not so good is that space wiring is a hassle, tends to result in a fragile unit that will fall apart at inopportune times, and usually only manifests itself when all the screws are down. So it's really hard to figure out what's going on and why it's failing. So the solution I suggested was to just use a small low-cost circuit board to do that. It's a little less flexible in size, but we can still make one that'll fit within, and for my purpose, the standard is an HO EMD scale. I was discussing this with some N-scale people yesterday, and the answer is the technology isn't quite there even for the people who want to go do it with surface mount and a whole lot of technologies that are a little beyond the soldering ability of the average model railroader. So anyway, as I say, the question was more finding out what readily available parts and values there were and tweaking the app a little bit. And for that, I followed my #1 rule of getting good at things, which is hang out with people who are better than you, which is basically what the PCR is all about. So I asked the Marx brothers, Schutzer and Guries, and we came up with a couple of part substitutions for the diodes that allowed us to use smaller diodes that dissipated less heat, which, you know, is good news because we're using less power and getting the same benefit. And it also means that the devices are smaller, so we can actually make this thing work. You know, anybody who wants to talk about this slide, contact me offline or we'll pick it up in the questions. The prototype, which went out about a week after our initial discussion, went to Guy Cantwell. Here's a picture of it. This is based on some caps that Phil was kind enough to send me. Unfortunately, these tiny little 5mm diameter guys are no longer stocked by any of the major distributors. So the final cap is a little bit larger, but the size, the dimensions are, say again? Are such that it fits nicely into, and I think this is a narrow gauge locomotive. So he's done a tender install. You can see he just wrapped a little tape in the lower right there around the Keep Alive, and it's working fine with the Soundtrax unit. Worked first time. The next I heard from Guy, other than you know, it's alive message, was an order for 5 of the panels, so he obviously liked it. Here's what the final product looks like. On the left, you can see the top and bottom of the board. On the right, you can see it with just the passives, which is essentially the charging and discharge circuit, because the capacitors are big and are kind of fit in between the diodes and resistors, and in an attempt to save some space. So you can see this is a tough thing to assemble. It's got 9 components and 2 wires, so pretty easy to deal with. And again, it's all through holes, so you don't need any special soldering equipment. You don't need to work under a magnifier. You know, if you're comfortable with any kind of electrical soldering, this should be no problem. As I say, my standard was it needed to fit within an EMD shell, and here's an SD40-2 that I've been working on for, I don't know, about 2 years. I had to blow the dust off it to take this picture. You can see the ditch lights, wires. That's what that fuzz on the right is. And there's the Keep Alive, and with a little bit of milling or filing, there's plenty of room to get it in there over a decoder and an Athearn frame. Obviously depends on how much metal's in the frame you start with and all of those issues. Here's another shot of Guy's installation. And here's a couple of examples if you were to build one. So the bill of materials part is, you know, 5 times $1.26 for the super caps is kind of your dominating feature. So you've got about $6.50 worth of caps. Oh golly, you know, another 50 cents maybe of resistors, and this is buying them one by one. I mean, their prices go down rapidly, even in tens. But you do have to buy the panel, so I've got a few options for you on that. You know, the thing that you will need to deal with DigiKey, and by the way, I created some shopping carts for you, so if you want to go buy it, you don't have to go through their part selector and figure out what you need. This is just click on this link and it'll take you to the list of stuff you can order. And I've got one for 1 unit and one for 10 units. What you'll immediately find at 1 unit is you're dominated by shipping. I would suggest shipping it first class mail. It should come out to be $4.99. And there'll be some tariff surcharges and yada, yada, yada. You know, if you buy it this way, you'll be at about 20 bucks. Here's the bill of material, you know, at the 10s. And let's see here, the window showing all the other speakers here is on top of this. So you can make 10 for somewhere around 65, maybe a little bit
Seth,
more.
you can get rid of that by clicking up at the top. There's like a flat bar. If you click
Right.
on it, it'll, yeah, there you go.
Right. I just dragged it out of the way. You know, I like to see who wants to say something, so I was trying to be clever and, as usual, screwed myself. So, you know, that kind of gives you an idea. So for a couple of guys getting together on it or a club project, this is a very economical way to go. I created, since I've got a little website with these parts, you know, a special for you because I love you price. I'll sell you the panel of 10 for $5. I also bought enough parts to make up some kits. So this is a kit that just has enough stuff to build one. And that's about cost. You know, I've got to pay PayPal and all this stuff. So that's what it comes out to. So hopefully those are some, you know, not painful price points if you want to buy one and play with it. And let's see, what else do we have here? References and links. All the files are up there. You can download it from my GitHub page if you're an Eagle guy and you like it, but you want to tweak something, or you know how to buy circuit boards from your favorite Osh Park in Utah, or any of your favorite Chinese. There's a link to the product page. There's a link to Larry's original article. And with that, I'll take any questions. Put you all to sleep.
So Seth, you mentioned that the classic capacitor keep alives are for a few seconds. How long will these supercaps last without power?
Guy said that he could run his, I think it was HON3, might have been just HO locomotive for about a minute. One little test I did is I took a lead in series with, I think, a 1K resistor and charged the thing up, and it, you know, charged up to the point where my bench supply wasn't showing it drawing any current in less than a minute. And then I went off to dinner and, you know, made dinner, cleaned the dishes, talked to my wife for a while, finished reading the paper, and came back and the light was still lit. So
Okay, wow.
Well, just as a comment, so the ones I built one, and actually on an ON30, you know, Bachmann ON30 with a Soundtrax decoder, if you turn the playout power off, the sound stays on. You leave the room, walk down the hall, walk back by the room, the sound's still on 2 minutes later.
yeah, that's consistent.
Yeah, and I actually had one run off the tracks on the module where somebody ran it, flipped a switch, and it ran 2 feet onto the next module across the grass. So
I was just going to say that one of the reasons for this is if you have a lift out section or a swing gate or whatever, and you have a power cutoff, you kind of want to know how long this thing's going to run before it runs off the end of your layout.
Well, that has been a concern about keep alives for me always. And I've had a few bad operating experiences where, you know, on older layouts, particularly where maybe some of the industrial areas really haven't been modified since DC days because they just took the cab switching switch out and left it there. I've had some cases where, sure enough, the locomotive ran into the dead track. It's not connected to anything and there's no way to stop it. And then it goes and runs way back into the way back where you can't reach it. Of course, the real disaster was where it runs through the stopping section. Now, more modern decoders that are designed for keep alives and have the pads for them, and happily this is sort of independent of whose keep alive you use, do have provisions where they will turn themselves off if they haven't heard DCC signal for a second or two. So, they try to protect against that. I was just reading an article yesterday where apparently some of the Europeans have a trick where in the dead sections they just put a diode in series, and if they start seeing an asymmetric signal because it's blocked by the diode, they decide that, oh, that must be because it was supposed to be a stopping block, and the decoder responds to that. So you need to do a little research and see what your decoder supports.
So the reverse of that is when they're charging, I don't know how quickly they charge. Do they create a surge to your power district cutoffs, whatever you're using?
Well, the good news is no. That's what the little diode on top, and I used a Schottky to have less voltage drop across it, and that allowed us to use a smaller value. So that diode is not in play when you're discharging, but when you're charging, it routes you through a pair of resistors with an effective resistance of about 100 ohms. And that limits you to, since it's about 10 to 12 volts, roughly 100, 110 milliamps. And, generally that's fine. Certainly one at a time, they're not going to cause a problem. I guess if you had 30 of them turn on all at once, that'd give you a 3 amp draw. But we normally work with a 5 amp booster and a 3.2 amp trip on a PSX. So, I'd say try to have less than 20 locomotives in the block.
Yeah, that's a pretty safe bet.
I have to say on the modular layout, we've probably got 10 or 15 with Keep Alives on it. We turn it on in the morning and it comes on fine. But that's across probably 3 to 4 or 5 amp boosters. But
yeah, exactly. So per booster, it's well under an amp.
Right.
And, that if you're having problems with well under an amp of startup current, you got other problems.
Stupid question number 325. Hooking up onto one of the older decoders, which two leads on the decoder do you run through Keep Alive? Is it the track power? How do you?
No, not on the track power. You don't, because then it'll try and filter your DCC. If you can find the bridge rectifier, the output of the bridge rectifier is probably the place to go.
That's on the decoder.
Leads of the bridge. At this point, you're getting into unauthorized surgery, but, that's probably the place to put it.
Okay.
there was a website, I'll go see if I can find it again, that actually had a list of a whole bunch of decoders and showed you where to find the wires. But basically the way they all work is the track comes into a rectifier bridge that's on the circuit board, and it'll be basically four diodes. You'll see them on the board, and then the output of that the other way is where you want to connect to, because that's the unfiltered DC power.
Right, exactly. And you get one of the benefits, of course, is that it's, a wonderful filter. I mean, you're just not going to get a better filter. So, a little bit of internal resistance because of the charging resistor, but, it's very good for that. I again echo what Phil said. I have seen this website. I have certainly had a number of decoders show up at my workbench saying, could you put this thing on? And I'm always, sure, tell me where you want me to solder it. But, it's at your own risk. So, on the other hand, if it's that old in the decoder, it probably doesn't owe you anything. And, the worst you're out is a decoder that didn't work very well.
I'm going to add stupid question 327 after Pat's, which is, will the locomotive still respond to the emergency brake on a DCC system, which does the whole layout, everybody stop? Okay, so it will honor that even though it's fully charged. You're not going to see your locomotive running for 3 minutes after everybody else has ground to a halt.
Right. So that's a really good question, because there's two different things going on, but the behavior to the user is similar. So in one case, you have the stopping block, which says, I will stop it by removing its power. Well, that doesn't work very well with a Keep Alive, because we've decoupled the locomotive from at least any immediate power interruption. The other one is the DCC command station sent out a calling all cars request, telling everybody stop right now. So as long as you haven't blundered into some place where there's no DCC command available, the emergency stop will work fine, both on the individual locomotive and the system-wide basis.
Now, if you're on a dirty stretch of track and the keep alive is keeping it running and it doesn't hear the emergency stop, does the command station repeatedly send it?
Well, the problem.
That's a really good question. Does anybody know?
Well, I don't know if it repeats it, but the problem that you're talking about is if you're in that dead section before the gate, the end of the layout, and you've killed it, that's when you hit the damned emergency button. When there's, and then it's not going to work unless you have. This is a different topic. Unless you have Wi-Fi DCC instead of through the rails DCC, then it would work.
So it's always good to have a physical blockade before the bridge that's out.
Yeah, I think I would use a hinge pin or something.
So just a question.
I could think of some kludges that might work, but frankly, it's probably better to just be safe and use the mechanical solution.
So actually on the bridge we did in Pleasanton, we put a relay in to cut the blocks off, which are probably long enough that they would stop. But if you open the gate when an engine was only a couple of feet away, it wouldn't. We have actually talked about just putting some pins that would come up about 1.5 inches, just right in the middle of the tracks, that would just basically, an engine would hit them and you'd sacrifice a little bit of a bump on the front of it, hoping it would slow down, and just connect that to a tortoise to run them up and down. So when the relay flops out, they go up. When the relay goes the other way, they come down. I haven't done it, but I think that's probably the best way to do it to protect it. And by the way, you have to do the same thing when people start doing dead rail, because dead rail we've had a couple of people come with dead rail. The other thing we actually talked about, we have the lift out because we have the relay, was putting a red light up above it that actually would come on like a side, one of those rotating beacon lights that would let people all over the layout know, hey, this bridge is open. We only have one bridge, so you could actually put a couple of those up that would actually turn on so anybody operating would know a bridge is open, just as a warning.
Couldn't it even be something as simple as spring loaded? The bridge pushes the pin down, you lift the bridge up.
I like that even
up.
better. Yeah.
That's no necessary electrical connection. It's just a simple mechanical. Bridge goes down, pushes the pin down.
Yep.
Idiot resistant.
Well, I don't know. You can't make it foolproof because fools are too inventive.
But the other thing you could do, and it didn't do this, but you could do, it's really pretty easy, is you could just run wires a little bit farther and put in 2 more relays and take the next 2 blocks out too. So literally you could take it out. So you took everything out 30 feet from the bridge when you open the bridge. And that way, if everybody just knows when you open the bridge, you look and don't see if there are any trains within 10 feet on either side, you open the bridge, they'll never get there. Because,
Is that actual feet or scale feet?
Actual feet, real feet, yeah.
Well, the other thing with having a little longer stopping section is that it gives you a chance of protecting against the guy who's backing.
Right. Yeah.
Right, because you may start losing the caboose and cars over the back, long before the locomotive hits the stopping block. So, anyway, like any technology, I mean, there are sometimes unintended consequences, but they're manageable. And anyway, so if you want to do it, I think this is a fairly convenient and inexpensive solution. And hope I've offered some convenient ways to, take advantage of it. And this kind of goes back to my clinic up at the Elks about a year ago. Remember when we could meet at the Elks? And I was showing some clever things you could do with printed circuit boards, using them as the floors of buildings and then a substrate to handle the building lighting. So, you can use these little circuit boards to do a whole lot of things because they're small and they're convenient, and they can be used as structural components also. So again, neat technology should be in your bag of tricks. If you have a question, there are several of us who do this stuff. Feel free to call and take a look. And there's the board.
Super.